Hello friends, welcome to YD Zone. So today I will be explaining you Harker's variation diagram with I think nearly it is more than so many graphs we are going to draw today, but only in one graph paper. Okay, so the requirements are one graph paper, pencil, scale, and eraser. So be ready with that. And if you have any example table for you, or a question which is given by your sir, so you can take that graph also, and you can do it with that. Otherwise, I will be explaining you with an example. So the example is ready, and today we have to work a lot. I think so because it will take too much time. If I will make a whole video, then it will be more than 1 hour. I'm sure of it. So I will be pausing the video whenever I will point. In the starting, I will show what I am doing, but after that, I will pause the video and then again I will resume the video. Okay. So if you like the video, don't forget to like it because it took a lot of hard work to all to make it. So please like the video and share with your friends who want to learn Harker's variation diagram, and subscribe the channel to get more content about geology. Okay, and don't forget to press the notification bell icon also. So without wasting time, let's start the video, guys. Friends, today I will tell you how to do Harker's variation diagram. It's how to draw it on a graph paper. So whenever you will do a Harker's variation diagram, you will be getting a table form like this of SiO2 and other oxides. So see here, this is the first line is of SiO2 and the other lines are of oxides. This is Al2O3, TiO2, FeO, Fe2O3, MgO, CaO, Na2O, MnO, K2O and P2O5, right? So now we have to draw this on this graph paper. Okay. So there's all minerals we have to do. This is given of sample 1, sample 2, sample 3, sample 4, sample 5. Okay, so we have to draw all the samples and then we have to draw to connect all those dots, and after that we will see the graph is positive graph or negative graph. Okay, this is called as Harker's variation diagram. Okay, so now we have to draw a graph. So first we have to know its scale. What is the scale of a graph? The scale is the very important part, right? So we will find out what scale should we take. So as we can see here, SiO2 is at 70.65. So 70 I think is the highest number. 71 is highest. 70.65 is the highest. And here the lowest is 69, 59, 50, 46. Okay. 46 is the lowest number. Okay. So 46 is the lowest number. So we have to take. So we will take. See, what we will do is that we will take SiO2 on this x-axis, and on y-axis we will take all the oxides. Okay. All the oxides we will take on this y-axis, and x-axis we will take SiO2. So I will first make the lines here. So we'll make it clear. Yeah, I made these lines. Yeah. Right. So this is the y-axis. I will write here. Y-axis. So we have to take oxides on this side, y-axis. So I will write here oxides. I have written just going this direction, right? On x-axis we will be drawing SiO2. Let me write SiO2 here. So I have written here SiO2 also. I'm writing, sorry, SiO2 is on the this direction. Okay. Oxides means all those Al2O3, TiO2, FeO, Fe2O3, MgO, CaO, Na2O, MnO, K2 and P2O5. Now we have drawn SiO2 right here x-axis. So first thing is we have to find out the scale now. So first we'll find out for x-axis and then on for y-axis. So x-axis is SiO2. Okay. So x-axis, the maximum point is 71 and the minimum point is 46.98. That means 47. Okay, we will take it as a 46 the minimum point, and the maximum point is 71 or 72 we can take. So if we started from 0 and we gave here 0, 1, 2, 3, 4, 5, Means 1 centimeter equals to 71%. If you will give this like this, that will be a very long graph. It don't come this. So we can do one thing. You remember this thing when you were in schools? We have taught that if you don't want to start, see over here the lowest point is 46. So we can start from this now. We will break this line here. See, by breaking this line like this, we can do here, we can start here from 46, this point. This is 0, right? This is 0 for y-axis and x-axis. Okay. So we have made here this mountain type shape. By this indicates that we have break the line and we are continuing it from 46. Okay, so I will make this 46. This is 46, and now I will take, if still I will take 46, 47, 14, 49, 50, 51, 52, 53, 54, 55. Still we cannot complete till here 70, right? So what I will take is that I will take 1 centimeter equals to 2%. So this is 46. So the next one will be 48, then 50, then 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72. Let me check, can we make it here or yeah. Okay, so this 70 and 72 we got here. Now yeah, if we took it as a 1 centimeter equals to 1%, then it will come till here. Here is a 71. So it is very long and it is difficult to understand them. Actually, when we take this small scale, it is difficult for us to then calculate the point, but we will manage to do it because the graph is not big. So I will make a mark here, and this is x-axis. So I had made here x-axis. Okay, so we have made our SiO2 here. Now we have done, because the maximum point is on SiO2, maximum point is 70.65 and the minimum is 46. That's why we break down the line and started from here 46, and our scale is here 1 centimeter equals to 2%. Okay, so now for oxides. Okay, so this all are the oxides. So we have to find out the scale for this. So we'll see which is the smallest value. So I think this is the smallest value, 0.03, 0.03, okay, 0.03 is the smallest. So which means 0.03 is nearly, okay, and the maximum value is 15, right? See, 15.46, okay. 15.53 is the maximum value. 15.53 and 0.03 is the lowest value. So we will calculate the number of lines here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 is coming here. 16 is coming here. So we can make here as a 1 only. 1 centimeter equals to 1%. Okay. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and this is 16. It's 13, 12, 11. So every time I read pencil, let's get. Actually, I'm writing so here. Pressure is exerting. Okay, no problem. 5, 4, 3, 2, 1. Okay. Same way here also. Actually, I have the habit of doing this, so that's why I'm doing. Okay, let it be. Yeah. Okay, so done friends, this also. Now how to plot. Okay, so what you have to do is that you have to see SiO2 is 70.65. Okay, so we will do it first for Al2O3. Okay, SiO2 is 70.65, Al2O3 is 15.09. Okay. So SiO2 is here at this x-axis and okay, sorry, I haven't written here scale. Let me write a scale. Here we have to write scale. Okay. Y-axis, x-axis, that is 1 centimeter. Here also 1 centimeter. So on y-axis 1 centimeter equals to 1%. On x-axis 1 centimeter equals to 2%. Okay, so our x-axis is ready. We will make a box for it. So our box, yeah. Our box is also ready. Yeah, so our scale box is ready here. Okay, so now we have to plot the point. Okay, so our first point is 70.65 in SiO2. So SiO2 is on x-axis. So here is our 70 and it is 70 and this is 72. So in the middle of it, it is 71. So we'll count. So here each point 1 means each here 1 millimeter equals to 0.2%. Okay, 70, then 70.2, 70.3, 70.4, 70.3, sorry, 70.2, this is 70, then 70.2, then 70.4, then 70.6. Okay, so the third line we have to calculate from here, and we want, and the Al2O3 is 15.09. Okay, so we will just keep a line here on our third line. This is kept. Okay, and in this side we want 15.09, which is Al2O3 oxides. This is oxides. So here 15 is here, so 15.09, that is 15.1. Okay, so here 1 millimeter means here 1 centimeter equals to 1%. So 1 millimeter equals to 0.1%. On the x-axis 1 millimeter equals to 0.2%. So this is 15.09 we record. So that is approximately 15.01%. So we'll just take the first line after the 15. So we have to see that as corresponding line. This comes here, and here we want to take the third line, that is here. Okay, let me check. 2, 3. This is the line. This is the dot. Okay, I have made a dot here and a circle. Okay. Now second one is in the same way we will do of this also. 65.57 at SiO2 and 15.46 on oxide row. So where is 15.46? Okay, sorry, first we find 65.57. So here it is 64, here 66. So in the middle line is of 65, and we want 65.57. Then 60.57. 60.57, so it is 65.6 as a whole you can calculate. So this 65, so if this is 65, then 65.2, 65.4, then 65.6. Okay, the third line again. Okay, so this I will keep here my scale. Yeah, and here our next point is 15.46. So we'll just calculate the point 15.46 where it is. This is 15 is here. Then 0.1, 0.2, 0.3, 0.4. Okay, 0.46. So that is point. Okay, we will take between the fourth and fifth line. A point between the fourth and fifth line. It's here. 15.46 will be somewhere here. This is our point 2. Then the next is 59.17 and 15.353. So 59.17 it is here. So 59.17 can be whole as 59.2. 50 is here, 60 is here. 59 is the middle row, and the 59.17, that is approximately 59.2. So just a very second line, this is 59, then 0.2, this is this one, second line, first line only. So 59 will be here, and we want 15.53. So okay, this is 15.5, so this center is 15.5, just above which will be 15.3. okay, this 15.5 comes here, 15.53 will be just little bit above this. So we want here the only first row. I have made this circle also, this point also. Now the fourth point is 50.02, 14.37. So this is 50.02, so 50 is here, so 50.02, that is approximately 50 only, right? So 50 is here, and the next digit is 14.37. So we will keep a scale here on 50 and 14.37. This is 14. 14.37 is 14.4 only, right? Approximately 14, then 0.1, 14.2, 14.3, and then 14.4. So it will be at this point. Dot made. Okay, the fourth point is also made. And now the last one is 46.98 upon 6.35. Okay, sorry, 6.35 and 46.98. So 46 is here, and 46.98, that is equal to 47 only. So in the center line, this line between 47 and 47, this is the line of 46.98, that is 47, and AR203 is 6.35. So we will calculate here where is 6.35. okay, this is 6.36, then 0.1, then 0.2, then 0.3, and then the 0.3. After that, in the middle of 0.3 and 0.4, it will be 0.5, right? So 6.35 you have to take, then this is the number. So we have successfully completed this line. Now we will draw a line, a freehand drawing, okay, just from here to here. So let's draw it. Drawn from here till here. Okay, now again it is going downward. It came down here. Now it is going directly. It is very difficult to draw a free hand drawing. Okay, so this is our first graph, that is of SiO2 and Al2O3. okay, so you can write on this line SiO2 and Al2O3 so that you can know this is the first graph. So in the same way, we have to draw this all oxides with SiO2. okay, because SiO2 is on the x-axis and oxides is on the y-axis. So now we have drawn of Al2O3. Now in the similar way, we will draw of TiO2, FeO, Fe2O3, MgO, CaO. So I will pause the video and I will show you after drawing each graph, because if I will record the whole video then it will be more than 1 hour. Okay, so I will try to record much of the things, but okay, I will try. Still I will try, because for noting down the points it requires time. So here SiO2 is 70.65 and TiO2 is 0.86. okay, so where is 70.65? So this is the same row. 70.65 row is the same row. Okay, this is the third line only, right? This is 70 and 70.65 means 70 point. So this is 70, then 0.2, then 0.4, then 0.6. That will be 70.65. The third line from 70. 1, 2, 3. Okay. And our TiO2 is 0.86. So which is just downside only. Here only it is. So here it is 0.86. So here it is 0. Then 0.1, 0.2, 0.3, 0.4, 0.5. Then 0.6, 0.7, 0.8. The 8th line is of 0.8 and we want 86. So it will be between the 8th line and the 9th line. this is our 70.123 and between 8th line and 9th line. Okay, I have drawn this. Now in the similar way we will see of the 65.57 where it is. So 65.57 is in this row. This is 65. So 0.57 means 65.6, right? So the third line here also. 0.2, 0.4, 0.6. This 60. This is the from 65. It is the third line. Okay. And here we want T out is 0.77. So it is equal. 0.77 is equal to 0.8. So we will take the 8th line. Oh, sorry, guys. I have done here a wrong mistake. It was 0.86. So it is here. Wait a minute, let me think. 70.65 and then it will be okay, it will be here. 1, 2, 3. Yeah. See, actually, this is why we required a lot of time to plot all these points. And I think I will be requiring more than 1 hour to plot all these points. So I will be pausing the video and I will be resuming the video and I will show you each graph, each line after drawing one graph. Okay. So now the AR203 and SiO2 graph is line is made, because you can see. Now I will be making TiO2 line and after that I will pause the video for FEO. And after I will make FEO line, then I will show you how FEO graph is there. Okay. So where is TiO2 0.86 and the second one is 65.57 and this is 0.77. This is 65, 65. That is 65.6, 64.2, 0.4, 0.6. Okay, 61.6 and then it is here. Okay, it's little bit the downside of that this, because it is 0.77 it is 0.86, so small, you can see it's not visible, but if you draw a line you can see it is little going downward. Third is 59.17 and it is 0.99, that is equal to 1 only. It is 59.17. So where is 59? 59 is here, 59 is here. 59.17, that is 59.2 we can say, and it is 1 on this point, so it will be the first line from here. Okay, so here the graph went upside. Okay, third point is 50.02 and 1.15. Okay, 50.02 is we can calculate 50. So this is 50. Then what is that? The next is 1.15. So it is 1.1, 0.2. So it is in between of that. This is the fourth point. The fifth point is 46.98, 2.44. So 46.98, that is equal to 47. This is the line of this. 47 line is here. After that, we want 2.44, right? So this is 2. 0.1, 0.2, 0.3, 0.4, and we want 0.44. So above this is 0.5. So we will be taking a line between 4 and 5. Okay, so we have made this line also. If you are good in all these things, means if you are good in concentrating well and focusing well on the points, because you have to calculate fast, you have to see, and you have to see very properly which line is this, because they are millimeter line na, that is the problem. And if your scale is big, then it is more good, but we don't have a bigger graph, that is the problem. Okay, as you can see, the line has been drawn by me. This is the line. I will make it darker here also. and here also. Okay, so we have made a line. You can see this line. So this is the graph of SiO2 and TiO2. So in the same way, we have to make a graph of SiO2 and FeO. So we will make it, and I will now pause the video because if I will make this also, then it will be a very long video. I will show you how I am making. Let's try to see the point. This is 70.65. So this is 70. This is SiO2 on this x-axis. We will just see where 70.65 comes. We will keep a scale there on 70.65. And then we will see where is our third one, which is FeO. FeO is 1.83, so it will be 1.8. So it is 1 here, then 0.1, 0.2, 0.3, 0.4, 0.6, 0.7, and this 0.8 is here. So we'll have to just mark the point, okay. So yeah, as I mark the first point, now I will be marking all the points, then I will show you how the line is made. Okay, because if I will make again that, I will show you how I am drawing the points. Okay, but I was showing you point 1 and point 2, then it will take a lot of time. Friends, you can see here, I have made a line of, graph of SiO2 and FeO. So for the first point is here, 70.65 to 1.83, then 65.57, 3.13. According to this table, I have made this line, you can see here. So it is intersecting here. So no need to worry about because we have to draw so many lines in a one single table. So it is intersecting, no problem, okay. So I will make another graph that is of SiO2 and Fe2O3. Okay, so I will pause the video once again. You can see this. It's looking like this, okay. So I am pausing the video now. Here I have made the second of Fe2O3 and SiO2 also. You can see here, see here in the first case, SiO2 is 70.65 and Fe2O3 is 0.80, okay, and TiO2 was 0.86, so it nearly overlap each other, 0.8 and 0.86. So see, this is only one circle is there, you can see here, okay. This is the first line. This downside line is of TiO2 and the upside line is of Fe2O3. Okay. Whenever we will all compute of MgO, CO, Na2O, MnO, K2O and P2O5, we will mark these lines. We will write here TiO2, Al2O3, so that we can know which line is which one. Okay. So now you can see this whole graph. This is the first line, then this is second, this is third, this is fourth. And now I will be giving the fifth line, that is MgO. SiO2 ratio MgO. I will draw this graph now. So I will pause the video. So friends, from this table, actually we have done a mistake here. The 15 was not the highest one. We thought 15.453 is the highest, but the highest was 19.90. Okay. So because of which there is a problem now. I have the table till 16 only. I don't have more than 19. Either I make it till it will be only 17 till here. So I need to redraw it. But what we can do is that now we know it is 19.90. Okay, and it is at 46.98. It is 46.98. Okay. So what I will do now is that I will tell you which are the 4 points. This is the first point where it is. Okay, this is the first point. Okay, at 0.80. Then the second point is at 1.94. Then 2.05. Then 1.95. Okay. Sorry, 7.23. Sorry. I misunderstood the graphs. The first graph is as 0.53. It is here. Okay. Then 1.39. Then 2.94. Then 7.23. And the fifth one is 19.90. Okay. So 19.90 is very high. It is not here. So we will draw a line till here, which will go till here. Means we will show that it is going above the graph. Okay. So I will show you. First we will draw till here. That is from. It will be going like here. And then from here to here it went. So again from here till here it went. Okay. So at point 46.98, that is 47. So on this line, On this line only it will meet to 19, but not here because it is 16, then here it is 17, then 18, then it is going out of the graph. That's right. It will go out of the, if you will write here 17, then here 18 and here 19, then it will go till 19 till here. So what we will do is that we don't have now, we haven't written here 19. Okay, so I will make this line just till that, just 47 line is this, so I will make it till here. See, I made the line which is going above the graph, which is indicating that if you have done this, you can do this. Otherwise, you can write here the 17, 18, 19, then you can make it. Okay, no problem. But there is this problem, so I am making it upside. This is also right, no need to worry about it. Okay. So this graph is going directly downward. You can see this thing. So I will be marking it again till properly. I will make the ends properly. Yeah. So either I can do one more thing. I will write here 19 centimeter, 19. Okay. Here. I will make a dot here outside of graph and I will write here 19. So if your sir or someone will say it is, they will understand this is the graph of 19. Okay. Yeah, this is over till here. Okay. So this is the graph of MgO and SiO2. So next time please share it properly so that there is no problem like this. That was a big problem, right? How can we draw it? So we made a line directly. So why these points are, what these points will tell us is to us that whether the graph is increasing or decreasing. Means when SiO2 increases, the proportion of oxide was increased or decreased. For example, in this Al2O3 graph, this is the first one, see here. So Al2O3 started from 47 and it went on increasing, right? It went on increasing only. Means the graph was positive. Started here, but it didn't ended here. It ended here, upside. So with the increase of SiO2, Al2O3 also increases. So in the same way, we will see of all. For example, this graph, this one, this whole going downside, this three. First one is also going downside, the second one is also going downside, and here they both are also going downside. So these all graphs are in negative, right? Means where they started, they are not in the same range, they went downside. So we have to see whether the graph is positive and or not negative. Okay. So now I am pausing the video to make the SiO2 and CaO graph. So I have drawn the graph of SiO2 and CaO, that is 2.66, 3.23. I will show you. So the first one, this one, is 2.66. Then here 3. You see here the both are intersecting nearly. They are coinciding at the same place nearly, and then here it is the next point. The fourth point is here, and the fifth point, see here, it comes down. So what does this graph show of CaO is that when SiO2 increased from 48 till 50, it went on increasing. But as it will increase, the percentage of SiO2 as it will be increasing, the percentage of CaO will also be decreasing. Okay. First it will increase. With this increase, it will also increase from here to here. But after that, it will go on decreasing. So now we'll be drawing of SiO2 and Na2O. So now I have drawn the graph of Na2O with respect to SiO2. So this is the graph. First it was at 0.03, then it will increase, then again it will increase, and then it will decrease a little bit. But overall it was here, and as the SiO2 increased, it went on increasing. Okay, started here, ended here. So it is more than its initial point. So it was 0.03, it went to a very large extent, that is nearly 3 or 2.94. It is 2.94, I think so. 2.99. Okay. So now I will be drawing the next graph, that is of MnO and SiO2. So I am pausing the video once again. Okay friends, so I have drawn a graph of MnO and SiO2. So you can see here, so MnO at starting was 0.02, so it is nearly here only, downside only. Okay, so then it went to 0.04, then it went little bit higher to 0.06, you can see here. Then again it went to a much higher extent, that is 0.2, that is it will go little bit 2 millimeter upside, and it went again downside 0.2, so it is same 0.2 and 0.23. Okay, so now the last second is K2O. I will make with K2O. So I had made the graph of SiO2 and K2O also. So you can see this is the graph. See, first it went from 0.6, it was higher, it was 0.6, then it went to 0.44. Okay, then after increasing again SiO2 percentage, then it directly went to 3.2. Then again it increased as the SiO2 percentage increased, it went to 4.64, and then again it slightly increased by 4.69. Okay, so now we'll do the last one. So finally I'm going to do now SiO2 and P2O5. So we'll pause the video. So now I had drawn the last one, that is of P2O5. So it started from 0.15, nearly slightly here, you can see here. So I had made here, see here there are four dots, small, 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 right? As we have made all this on the one graph, that's why it is little bit looking mess up. But now we will be writing here names of these graphs. So here the P2O5 goes from 0.15 till upside 7.2, 0.72. Then it went again goes down to 0.44. Then again to 0.28. Then at 0.03 finally it touches. So this is a negative graph. Okay. So now I will be writing their name for its easy. We can see it easily. This is Al2O3 graph. Then the next one is, the next graph is which one? TiO, no, TiO2 is downside. Okay, which one is this graph? The last point is 15, 14 point something. Oh, sorry, 13. This one. This is the graph of FeO. FeO graph over, and which is this one? 6.35. This is Al2O3. Okay, this is over. This one is 7.9 or nearly, oh, it is 8, not 7.9. This is graph of CaO. So I will write here CaO right here. So this graph is coming here. Okay, CaO. This is a CaO graph. The next one, this is over, this is over, this is also over. This one is not over. This one is which? 19.1 MgO. I am writing so that we can understand which graph is going up, which graph is going down. Okay. If you don't want to write, you can not write, but if writing, it will be very easy to understand whether the graph is going upside or downside. Okay. This one is of Fe2O3. So I will write on this graph. This graph comes Fe2O3. I am checking the values here, and according to that I am writing here, because I am also confused which one is which graph. That's why I am writing here, so that I can easily see that. Now this one is TiO2 graph 2.44. This is TiO2, right? So we got TiO2 graph also. TiO2 graph is over. Now here there are three graphs, 1, 2 and 3, very small, right? Or maybe more than that. Let's see. So this is 0.6. So this is K2O graph. It came from here to here, then it went from here to here. This is K2O. K2O. Okay. Now the second graph is this one. Let's see where it is going on. This graph is going from here to here. Okay. That is, I think, from one. Okay. This is point 2. This is also point 2 3. This is the graph of MNO. Let's check it here. This is the graph of MNO. So we have to write it MNO here. This is the graph of MNO. Now here there I think one graph is ending or two graphs are ending. Let me see. Yeah, here two graphs are ending. See, this graph is also coming and this one also. So let's see. This is 0.15, 0.7. Okay. This graph is of P205, is going from here till here. P205. Okay. Now which one is left? This one is left, right? This is the graph of, let us check. It is ending at 3. So which graph started? Okay, adding of Na2. So this graph is of Na2O. So now let's check. Al2O3 over, TiO2 is here over, FeO, this is FeO, Fe2O3, where it is, this is Fe2O3, MgO, CaO, Na2O, where is Na2O, this is Na2O, MnO, okay, this is MnO, K2O, this is K2O, P2O5, this is P2O5, yeah. So we have drawn all these graphs. Now in a separate paper, means just like a blank paper or the another sheet, which you will keep it in the record book, you have to write the thing, whether the graph is positive or not. So to write it like this: Al2O3, the graph of Al2O3 and SiO2 is positive, because see, it started here and ended here. See, this is its initial point. So just you have to see is that you have to keep a scale on its initial point and you have to see the last point. So this is the last point of this graph. It is above this line or the below this line. If it is below this line, then it is negative. If it is above this line, it is positive. Okay. For example, the graph of FeO, it started at 15, nearly 15. See, and the last point is below the line. Okay, it is here somewhere. So that means the graph of FeO is negative. In a similar case, you can see of this K2O. K2O starting point is somewhere here. I think here. So K2O last point is here. So K2O is above the line, so it is positive. Okay, so in this way you have to write up all the oxides. Then here, this is Harker variation diagram we have drawn successfully. So here our Harker variation diagram is completed. So finally we did it. Okay, it's a very long video of nearly 40 minutes and more than it, right? So you can imagine I have paused the video already. So how much time it took for me is more than 70-80 minutes, right? Or more than 90 or 100 minutes it took to me to do all this work and all this stuff. I hope all of you understood the video very well, and whatever I taught you and whatever I have told you steps, you will do according to that, and you will pass your practical exam in very good marks if this Harker's variation diagram comes in your exam. So please do a like. Just for a lot of time we have made it, because that's why we do a like. And if you understand, then comment in the comment section that how you like the video and what you want to do suggestion to me or any other things also. Just like if you want any topic to cover, I should cover that topic, so just comment down your topic and tell me what is the topic, and if you want to do the example also of the same topic, I will take the same example also. Other than this, if you have any practical work or anything, just write down in the comment section. I will make a video on that also. Again, other than this Harker's variation diagram, I have made videos on IOGS diagram, classification diagram, Niggli value form, and CF2 knockdown. So you can watch all those videos also. Okay, with example I have told with all its types and all. So you can watch all this also, and you can get good marks in your practical exam if you don't know how to do it. So thank you guys for watching the video. Hope so you will like the video and share with all of your friends who want to learn this Harker's variation diagram, and subscribe the channel because it's totally free. And to support us, please subscribe the channel.